Now that you've already learned how to find the area of composite figures where you're adding shapes up, now we're going to find the area of shaded regions, which is going to involve subtraction. So for number 1 in your notes, you should notice that you have a big white circle in the middle of that square. So essentially what we have is one big huge shaded region right now, and what we're going to be doing is removing that circle, and the leftover corners are going to be the shaded region that we have the area of. So what we're going to do is we're going to take the area of this big square right here, and we're going to remove the area of this circle. All right? So down here in the work, you've got the area for the square is side squared, so that's just the 10 by 10, which is 100. And we're now going to remove the area of this circle, pi r squared. Well, in the picture, what you can see is that we have the bottom length here is 10. So if this bottom length is 10, that means the diameter is 10. So half of that would be 5, which is what I'm plugging in for the radius. So for the circle, we're going to do pi r squared and get a 78.5 in the calculator. And now we're going to take that 100 and subtract the area of the circle, and we're going to get a 21.25. Okay? Now the other thing I want to point out is that this circle could also be removed and inverted. Notice that if I take this circle and try to shade it over here, do you guys see that? Let me get a line tool. Right there is half the circle, and then I can move it over here and fill in the other half. So if I take this circle and cut it in half, one of these sections can go right here, and this section can go over here. All right? So this is the exact same type of problem as this problem, where you have the 10 by 10 square and you just remove that circle that's on the interior of it, and we're going to get the same answer. Friendly reminder that since we're finding area, you want to label it with a squared. So we've got 21.5 square centimeters for this first problem. Now for number 2, what you guys see is something that looks kind of like a picture frame. And if the copier didn't do a very good job of letting you know what the shaded region was, it's that outer part right there. Again, kind of like a picture frame. So what we're going to do is we have this one big huge 8 by 10 figure, and when we take that 8 by 10, we're going to remove this 8 by 5. So in the work, we have the 8 by 10, which is the 80, and we are removing the 8 by 5, which is 40. And so the area that's remaining, this shaded region, is going to be 40 square feet. Now for number 3, take a look at the formula I have. We're going to take this circle and we're going to find the area of it, and then we're going to cut it up into fourths. That will narrow us down to this one section right here. Okay? So the first thing we're going to do is take the area of the entire circle, and then we're going to divide it by 4, which is going to narrow us down to this one section. Once we do that, what we're going to do is we have this shaded fourth of a circle, and we're now going to subtract this 1/2 base times height, and it's going to leave that little teeny tiny shaded region left over. So the full-on circle, we're going to take a fourth of it to be up in this area. Then we're going to remove the area of this triangle. Now for the radius of the circle, it's an 8 when you plug it in. So pi r squared is pi times 8 squared, so pi times 64. But then because we only wanted this 1/4 of the circle, we're going to divide by 4 and get a 50.24. And I want to remind you guys that the 50.24 is this entire fourth of the circle. That's the 50.24 right here. But now what we want to do is we want to remove the area of that triangle to have just this little shaded part left over. So now let's talk about the area of this triangle. It's an 8 by 8, which is 64, and half of that is 32. So the area of this triangle would be 32. So now what we're going to do is we're going to subtract the 32 from this 50.24, and this little shaded region that's left over is going to be 18.24 square centimeters. Now you'll notice in my work that it has switched from an AT to an AS. That's because we're no longer adding up to find a total area. We're now subtracting to find the area of a shaded region. And so the S here is what I'm using to represent the area of a shaded region. The S here is the side that's getting squared for the area of this square. So that takes care of this page for the area of these shaded regions. Now let's flip over. For number 5, what we're trying to do is find the area of something that's kind of like a tire. You guys are trying to find the area of this spare tire kind of looking thing. So first, we're going to take the area of this whole entire shaded circle, this whole thing, and then we're going to remove this little circle. All right? So let's focus first on this whole big, huge gray circle. And now what I'm going to do is I'm going to draw its radius. Okay? Now the 3 is only labeling this little part, and there's a 5 labeling this part, which means this whole radius is an 8 of the bigger circle. So when we're trying to find the area of the bigger circle, we're going to do pi r squared, and its radius is this 8. So 8 squared times 3.14 is going to be a 200.96. And that is the area of this huge, big, fat gray circle. Now what we're going to do, though, is we're going to remove, we're going to remove that. Oops, sorry, guys. Let's get rid of this circle now. And this circle had a radius of just the 5. So when you do this circle, pi r squared, 5 times 5 is 25, times the 3.14, we get 78.5. So the big, huge gray circle, now minus that one, leaves the tube kind of thing left over, and we're going to get 122.46 square centimeters for this shaded region, which is kind of like a tire. Now over here for number 6, what we've got, to help you see this, I'm going to trace it. We've got one big, huge square. That's a 14 by 14. And we're going to remove 1, 2, 3, 4 squares. So that's what my work says. We're going to take the area of one big square and we're going to remove 4 of these little guys. All right, now let me just undo that so we can see all the dimensions in the picture. So the big square was a 10 plus 4. That's where I got this 14. So this is a 14 by 14, which is 196. And now this little one is a 5 by 5, which is 25. And we have 4 of those guys. So in my work, I'm doing the 196 minus 4 of the 25s, which is 100. So I'm going to have 96 square meters left over. Now number 7 is a little bit different than all of the problems that you've seen so far. If you remember in the simple interest unit, sometimes I gave you the interest and asked you to solve for that middle letter, the R, and that was the part that some of you struggled to do. So this problem's kind of like that, because with these figures, I'm telling you that there's a smaller one, here it is, inside of the bigger one, and I'm telling you that this whole shaded region of the entire bigger circle is 64. Okay, now, actually, sorry, let me back up with that. It's saying that just the shaded area was 64. So let me back that up real quick. It's saying that just this tubular part is the 64. So the area of our shaded region is right here and has been given to us as the 64. What we want is the area of the whole big circle, which would be right here in the work, and then we would subtract that little guy to get the leftover 64. So for this one, what you're going to do is you're actually already given the shaded region, and that's over here. We want to find the area of the big, huge whole circle where we then subtract this little guy to leave the tube. So for the little guy, it told us that it had a radius right here of 6. We're just going to plug it in the formula. And we've got pi times the radius squared, so 3.14 times 36. And so for the area of this circle, we get 113.04. Now we know that this shaded stuff out here is 64. So all we need to do now is add that 64 to the circle we just found, 113.04, and we're going to get that the total area had to have been 177.04. So again, from the top, what we're saying is that if this thing had a total area of 177.04, so across the whole thing, it's 177.04, and you then subtract this circle, which had an area of 113.04, then the shaded region, which is here in purple now, that leftover part would be the 64 that they gave you in the problem. So this one, in my opinion, is one of the trickier problems so far. Now for number 8, you're going to see that we have 16 of these little circles nestled within a 32 by 32 square. So the 32 by 32 square, that's going to be easy to find that area. It's going to be 1024. It's the area of this big square, 1024. Now we need to remove 16 of these circles, 16 of the circles. I'm going to move this red line up to help you see that across one of the circles would be 8. 8 times 1, 2, 3, 4 would be the entire 32 across. That allows me to determine that if I'm trying to find the area of just one of these circles, the radius would be a 4. So down here, the area of one of the circles is pi r squared, 3.14 times 4 squared. But I'm multiplying it by 16 because there are 16 of these little circles. So the 16 circles, their area is 803.84. When we subtract that from the 1024, we get 220.16 square centimeters for the little leftover shaded stuff in the background. Now for number 9, the way it looks on your worksheet, you might be thinking that you're going to take this weird gray stuff and remove the red and the green. I'm actually going to suggest that we take one big huge rectangle, and I've outlined it here in blue to help you see it. Then we're going to take this one big huge rectangle and we're going to subtract this 11 by 22. That's going to come away right here. Then we're going to subtract this 18 by 6, which is the red, and that's going to get subtracted right here. The last thing we're going to do is remove this green part, which happens to be a 7 by 7, and it'll get subtracted last. Now let me erase to help you see how I got that it was a 7 by 7. Up here, if this side of the rectangle is 13 and this much of it is 6, so 6, this has to be 7. 7 plus 6 would be the 13. And this is one of those ones that doesn't quite look like a square, but it's definitely a 7 by 7. All right? So the big, huge rectangle was a 36 by 28. And 36 times 28 is 1008. That would be the whole big, huge rectangle. First, I'm going to remove this blue part, which is 242. Then we're going to remove this 18 by 6. The 18 by 6, which was the red part right here. That had an area of 108. And then the last thing we needed to remove was this green part up here, which was 49. And when we remove the blue, the red, and the green, that's going to leave us all of this shaded stuff left over. And that's going to be 609 square meters. That concludes the video for how to find the area of a shaded region by subtraction.